In this video, we're going to talk about the different types of sorting algorithms you need to know for the paper 1 exam. So if you look at the specification, you need to know how a merge sort works and how a bubble sort works. They're the two different algorithms you need to know, and you need to be able to compare them as well and explain the differences between the two. So what we're going to do in this video is we'll talk about the differences between the two, how they work, and answer some questions on how to kind of cover them, okay? To start with, let's start with the bubble sort, okay? I think the bubble sort is probably the best one to show. And to do this example, I'm going to use this question here from November 2020. So this question was quite nice because it gave the user a choice, or the candidate the choice of which one they wanted to do. So how a bubble sort works is a bubble sort basically works its way through the list. I'm going to show you how. It's better to show you rather than explain. So in the exam, what you'd probably do is you'd probably write out the, actually let me change my pen colour. Let me go to black. There we go. So we'd write out the numbers. So we've got 8, 4, 1, and 5. And the whole point of a sorting algorithm is to put these numbers into numeric order from lowest to highest, okay? Now at the moment, I can see they are not in the correct order. Now as a human being, I could quite easily order those. But computers, something like that, computers need a process to be able to order them and put them into order. So what we do is we start at the beginning of the list, which is position 8. And we compare 8 with 4. And we say, is 8 bigger than 4? Or is 4 less than 8? And yes, it is, okay? So what we do is we switch those around. So we get 4 and 8 switched around, and 1 and 5 stay the same. And then what happens is this pointer here moves up. So it moves up to here. So now we've got 4, 8, 1, 5. And we compare the next two numbers, 8 and 1. Is 8 bigger than 1? Yes, it is. So we switch those two around. So we get 4, 8, sorry, I lie. 4, 1, 8 and 5. There we go. Now our pointer is here, and we compare these two numbers. Is 8 bigger than 5? Yes, it is. So we switch them around. So we've got 4, 1, 5, and 8. And this is the end of our kind of first loop, as it's known. It's called, this is called a pass. So we get to the end here, and it goes, right, we're at the end of the loop. We're at the end of the pass. So now we go back to the start, and we start again. So that's pass number 1. Now on to pass number 2. We compare 4 and 1. Are 4 and 1 in the right order? Well, they're not, because 4 is bigger than 1. So we switch those around. So we get 1, 4, 5, and 8. Now we can see that those numbers are now in order. So as far as we're concerned with an exam question, we're done. But how a computer would do it was a computer would carry on. So it would then compare those two, they're fine. It would compare those two, they're fine. And then it would go back to the start again and do one final pass just to make sure they're all in the correct order. But you don't need to show that. It's just how a computer does it. So that is a bubble sort, okay? So it compares each number in its own little kind of entity on its own and kind of swaps them over. So let's have a look then at a merge sort. So a merge sort is slightly different, okay? Because a merge sort basically divide and conquer. It's that kind of method. So what I find it easier to almost put these in a table, in a list like this. So what we've got our table. So we've got 8, 4, 1, and 5, okay? The first part of this is you're not doing any sorting. You're just breaking them apart. So what we do is we chop the list in half like this, chop it in half. So we get 8 and 4 in its own little list, and then 1 and 5 over here in its own little list. And then what we do is we chop them in half again. Chop those in half. So now we have 8 on its own singular list, 4 on its own singular list, 1 on its own list, and now we've got 5 in its own, okay? And if you wanted to represent it, you could use arrows as well to show 8 goes to here, 4 goes to here, 1 goes to there, and 5 goes to there. So now that we've broken them down to their kind of individual formats, we can now build them back up. So this is where the kind of sorting happens. So now we build them up again in twos. So we compare these two numbers, okay? 8 and 4, are they in the right order? No, they're not, because 8 and 4 are on the wrong side. 8 is bigger than 4. So we rebuild that as 8 and 4 in a smaller list, like so. So they get switched around. So 4 goes there and 8 goes there. Now we look at the next two numbers, 1 and 5. They're actually in order. So they can be built up as they are, like so. And yeah, and that's they're now sorted. They're now in order. Yeah, that's fine. Sorry, I was checking I was still recording. So they're now in order, so that's good. And then the final stage is to build these two up together. So you build it up in twos. So now we just basically put them in order. So we put 1, 5, 4, and 8, and they are now sorted into numeric order, like so. And you almost get this kind of diamond shape where it gets bigger at the bottom, in the middle, then kind of goes back in at the bottom end there. It's important to note that, like, from a human doing this, it's actually quite easy to look at the numbers and reorganize them. But a merge sort is actually quite a complex algorithm. So to code this in a computer system is actually quite difficult. But for us, just doing it and visually putting numbers into the right order, just showing the process, is actually quite straightforward. So you split them in half. Once they're all in separate entities, you build them all back up. So let's look at some questions then. Okay, so this one here, this one is again a merge sort, but it's already done the first stage for you. So if I show you what it would look like 7, 3, 4, 1, 2, 8, 5, and 6. Sorry, I'm running out of room here with the screen. Let me move it over a little bit. There we go. So it would look like that to start with, and then it would have broke it down into 7, 3, 4, and 1 as its own list, and then 2, 8, 5, and 6 as its own list. Then it would split them again, 7, 3, 4, and 1, 2, and 8, and then 5 and 6 as its own list. And then finally, it would break them down to this here, this view, so that would jump to here, where we're at this point. So that bit's already done for you. So all we need to now is rebuild them up by comparing them. So we compare 7 and 3, they're in the wrong order. So 3 and 7 goes here. 4 and 1, they're in the wrong order. 1 and 4. 2 and 8 are fine. And 5 and 6 are also fine. They're in the correct order. Now we build them up again. So we do 2s combined again together. So we just reorganize these numbers into order. So 1, 3, 4, and 7. And then the smallest number is 2, then 5, then 6, then 8. And then finally, it's already done for you, but the computer would then build those two up together and put them into numeric order. And there you go. So say one advantage of the merge sort algorithm compared to the sorting algorithm in figure 2. So we can't see figure 2, but it's probably a bubble sort or something similar. So one advantage of using the merge sort is it's more efficient. It's more efficient because it uses less steps. Okay, so that's the benefit of this kind of sort. It uses less steps than a bubble sort. Okay, bubble sorts, as you can see, have to go around these different passes one at a time, comparing each number, even if they're not compared. Whereas the merge sort, it breaks them down and then rebuilds them up, and it's far more efficient. Okay, there we go. That is a merge sort and a bubble sort in a nutshell.